Welcome back, everyone. This is Frank with FJB Custom Woodcrafts. And in this tutorial, we will learn how to create the tool paths necessary to create the sign from the vectors we created in the last tutorial. So go ahead and open up the saved file we created from the last tutorial. Your screen should look something like this. The first thing we need to do is switch from the drawing tools to the toolpath tools. The drawing tools comprise the CAD portion of our software, whereas the toolpath tools comprise the CAM portion of our software. At the top left of our screen, you'll see an icon with a square containing a blue arrow pointing to the right. Clicking the icon will switch us to the toolpath tools, which will open on the right side of our screen. Before we dive into creating the toolpaths in any of our projects, it is very important to check the material setup section to be certain everything is correct. Without clicking the Set button, you will see a concise summary of data regarding our material setup. These include the Z0 position, material thickness, and XY datum position. Everything looks correct, but we should click the Set button and look at everything in more detail. If there are any changes to make, this is where to make them. The first item to check is the thickness of our material. Since we originally set our material thickness to 0.75 inches, that measurement should correspond to what is present in the thickness box. If for some reason our material thickness needs to be changed, you can simply type in the material thickness, hit enter on your keyboard, and the correct material thickness will be set. Another method to be certain that the material thickness is the same as what we originally entered upon creating the project, you can simply type Z equals, and the software will automatically enter the correct thickness. In the XY datum section, you should see the center of our material selected to be our XY datum position. This is what we had originally set our XY datum position to be when we created our project. As you'll recall, we did this originally to take advantage of symmetry in placing our vectors. We are now going to change the XY datum position to the bottom left. Click the bottom left toggle button and you'll see the XY datum position change from the center to the bottom left, where the small red square represents our XY datum position on our material. We do this because it is much easier to zero the X and Y coordinates on our CNC machine to a corner of our material rather than to the precise center. Since my particular machine's home position is in the bottom left, I always choose the bottom left for my XY datum position. You should choose your XY datum position depending upon your machine and what is easiest for you. In the Z0 section, confirm that the material surface is selected. We will ignore the model position in the material. The default settings should appear as you see on my screen. As we are not doing any 3D carving in this project, we don't have to worry about making any changes in this section. The next section represents the clearance gaps needed to taking into consideration your particular machine and your method of securing the material to your CNC bed. The Z1 clearance gap represents the height above the job at which it is safe for the cutter to move at rapid or maximum feed rate. The software will raise the bottom of the cutter to this height when it traverses the material. The Z2 plunge gap is by default set to the same value as the Z1 clearance gap. At this setting, there will be no rapid plunges. While some machines are not able to take advantage of this feature, setting Z2 to a value smaller than Z1 will cause your tool to plunge at a rapid feed rate to the specified distance above the material surface before changing to the specified plunge rate. This feature can save a considerable amount of time when your particular machine setup and project require a large value for Z1 to avoid clamps. For our purpose of simply learning the software and how to create toolpaths, we will assume that the default settings are reasonable and appropriate. The last section, Home Start Position, is where we can set the absolute position that the tool will begin moving from when we start a job and return to at the end of the job. Once everything is double-checked and set the way we want it, click the OK button. Directly below the Material Setup section is the Toolpath Operations section. Our first order of business will be to pocket out the area of the sign enclosed within the frame of the sign. Since the imported artwork will be V-carved into the pocketed area, we will only need to select the inner frame vector in addition to the text vectors. So let's select those vectors. Once we have those vectors selected, we will continue by selecting the Pocket Toolpath tool. After selecting the tool, its corresponding panel will open, allowing us to select parameters we desire to carve out the area. In our particular project, let's choose a cut depth of 1/4 of an inch. The start depth, of course, will be the surface of our material, so be certain that 0 is entered for that parameter. The next choice we are required to make is our tool selection. Typically, the software will automatically load the tool that we previously used the last time we created a pocket toolpath. If you already have a tool selected in this area, then left-click the tool in the enclosed box and select Remove. Now, click the Select button, and this will open your tool database. If this is your first time using the software, you will be presented with an Imperial toolset and a metric toolset. Any other toolsets you may have imported will also show up in the list. In my case, since I use several Amana bits, I previously imported all of the Amana bits, and so you will see that listed in my list. Make sure that the material selected at the top left is hardwood, and then click the plus icon to the left of the Imperial Tools section. For this particular job, we will select an end mill. So expand that portion by clicking its plus sign. In the default library, only 2 end mill sizes are available to choose from. If we don't see the end mill that we would like to use, we can simply create a new tool and fill in the appropriate tool parameters. Once saved, this tool will be available to us from the menu in the future. In this particular case, since we have a significant amount of open space to clear, we might consider using a larger end mill to clear the open space quicker. We can then follow that up with a much smaller end mill with the size appropriate to cut out the material between and within the lettering. In our case, let's use a 1/2 inch end mill so that we can save time pocketing out the material on our sign. We can select one of the end mills that is already available, and then go to the bottom left and click the Copy the Selected Tool group icon. From there, change the diameter to 0.5 inches. Assuming that our end mill has 2 flutes, no other changes are necessary, so we can click the Apply button. You will now notice a 1/2 inch end mill added to our end mill tools. We're not finished yet, however, because we have to click on the Create Settings button to input other parameters pertinent to the bit we will be using. In this particular case, we will input parameters that would be safe and appropriate for a theoretical machine. The geometry section is already appropriately filled in, so let's move on to the cutting parameters section. A reasonable pass depth in our theoretical case would be 1/2 of the diameter of our bit, which would be 1/4 of an inch. A standard step over for a pocketing tool path would be 40% of the width of the end mill, which amounts to 0.2 inches. These are the parameters that by default our software has provided automatically for us based upon the diameter of our end mill. Feeds and speeds are very important parameters. No single set of parameters is safe and appropriate for all CNC machines. These parameters need to be individualized for everyone's specific CNC machine to ensure safe, appropriate, and efficient machining. For our theoretical machine, we will change the spindle speed to 18,000 RPM and the feed rate to 150 inches per minute and a plunge rate of 70 inches per minute. As this is the first tool we will be using, make sure our tool number is set to 1 and click the Apply button. Our 1/2 inch end mill tool is now created in our tool database, and we can click the Close button. Going back to our tool selection in the toolpath panel, click the Select button and choose the 1/2 inch end mill. This will open up the tool database and display the parameters for our 1/2 inch end mill. As the parameters are correct, click the Select button and we can move on to the next section of the Pocket Toolpath panel. If we made a mistake and selected the wrong end mill, you simply select the incorrect end mill and click Remove. Lastly, I would like to comment on the Edit button. If we were to use our 1/2 inch end mill for another toolpath, but we wanted to change some of the parameters of our end mill for that particular toolpath without permanently changing the parameters that we originally entered in our tool database when we created that tool, you can simply click the Edit button, change the parameters that you would like, and click the OK button. This will apply the new parameters to this particular toolpath you're working on, but when you select the same tool in a different toolpath, the original parameters will still apply. In the Passes section of the Pocket Toolpath panel, you will see that the pocket will be cut in one pass, as our cut depth for this particular tool is set to 0.25 inches, and this is precisely the depth of cut we want to create. We can next choose whether we would like to use an offset or raster pattern of cutting. For the offset pattern, the bit will start in the center, cutting in concentric patterns outward until the entire pocket is cut. If the offset pattern is chosen, we can also choose either climb cutting or conventional cutting. For wood projects, I typically choose the raster pattern and set the raster angle so that the cutting occurs along the axis of the wood grain. In our model piece of material, the wood grain appears to run vertically. In this case, I would set the raster angle to 90 degrees. A profile pass is selected to clean up the inside edge after machining the pocket. I almost always select to have a profile pass performed to clean up any scalloping that may occur with the raster pattern of cutting. In this particular instance, I will choose a profile pass to be performed before rather than after carving out the pocket. If we choose a profile pass after the pocket is carved, there is a higher risk of tearing out portions of the descenders of the letters P and G in the bottom section of text, since they extend very closely to the inner frame and no wood would be present to laterally support the descenders. On the other hand, by performing the profile pass first, we avoid this issue altogether. We will leave the box ramp plunge moves unchecked in this tutorial. We will explain what plunge moves are and when you would use them in a later lesson. The next item to consider is whether or not we would like to define a pocket allowance. A pocket allowance will leave an amount of material you specify on the inside of the pocket for the profile pass to clean up. This is an option I always select to maximize the probability that the inside edge of the pocket will be smooth without any tool marks. I typically choose a small allowance of 0.02 inches. By leaving the Use Vector Selection order box unchecked, the software will optimize the toolpath to minimize cutting time. In our case, we will leave this option unchecked. If the box is checked, the software will machine individual pockets in the order you selected them. The last item reiterates our safe Z-value and home position that we previously selected confirmed in the material setup section. Since we are not carving a 3D model, leave the box for project toolpath onto 3D model unchecked. We manually chose our vectors, which is indicated in the vector selection area. We will discuss the vector selection selector option in a later lecture. But basically, this option would allow the software to automatically select vectors to machine based upon various properties or positions of the vectors that we choose beforehand. It is also a method that allows the user to create toolpath templates to reuse with similar projects in the future. The last step is to name our toolpath and click the Calculate button. I highly recommend changing the name so that it indicates both the type of toolpath file and the tool being used. Let's rename it Pocket 1/2 inch EM, where EM stands for end mill, and click the Calculate button. After you click the Calculate button, the Preview Toolpaths panel will open, and you will see the toolpath that you created in the Toolpaths section. We can now preview the toolpath by clicking the Preview Selected Toolpath button. When we click that button, you will see the toolpath being carved on your material. We can adjust the speed by using the speed slider. It is very important to review each toolpath to be certain that the result we obtain is what we originally intended. Sometimes we can overlook something, and if we don't check the toolpaths beforehand, we will not be happy with the result when we go to carve our project. By looking at the results, we can see that the main pocket is carved very nicely, but the lettering is not finished. This is because the 1/2 inch bit is too large to carve out areas that have a smaller curvature or are smaller in width than the diameter of our bit. We will therefore need to use a smaller bit to finish our pocketing. In order to finish our pocketing, let's close this panel and double-click the toolpath that we previously created. This will reopen the toolpath that we previously created and allow us to add another tool to finish the job. Since I have previously tried a 1/8 inch end mill and determined that that end mill is also too large to adequately complete the job, we will use a 1/16 inch end mill. Since we do not have one in our library, we need to create a new tool again. Let's select another tool. This will open up our tool database and allow us to create a new tool. I will select the 1/2 inch end mill and click the third icon from the bottom left, which will duplicate the 1/2 inch end mill. We will then change the diameter of the tool from 1/2 inch to 1/16 inch by typing 1 divided by 16 equals. The built-in calculator will convert the fraction into the corresponding decimal for us automatically. Next, we will enter the settings required for the particular bit we will be using. Click Apply. In the Settings panel, we will be using a 2-flute bit with a pass depth that is already appropriate for our theoretical case, which amounts to 1/2 of the diameter of the bit, and use a step over of 30%. The spindle speed of 18,000 is good, but let's change the feed rate to 40 and the plunge rate to 20. Also, change the tool number to tool number 2, and then let's apply those settings, and this will bring us back to the Pocket Toolpath panel on the right. Now, let's select the 1/16 inch end mill, and it will be added as a second tool in the toolbox after the 1/2 inch end mill. Let's calculate the updated toolpath, and you will see 2 toolpaths in the bottom of the Preview Toolpaths panel. The top tool represents the original 1/2 inch end mill, which is designated as the clearing pass, which will remove most of the material. We should change the name of the second item by right-clicking the item, rename, and changing the 1/2 inch to 1/16 inch. After hitting the Enter button, let's reset our preview and preview all toolpaths. The lettering is not as well defined as I expected, so let's double-click the 1/16 inch toolpath we just created and relook at the parameters in our Pocket Toolpath panel. I notice that the 1/16 inch toolpath is auto-set to offset rather than raster, even though the 1/2 inch end mill pass is still raster. Because of that, we can't select a profile toolpath for the 1/16 inch tool. That means the 0.02 inch allowance set in the smaller tool is not being cut away, making the letters not well defined as we expected. Let's get rid of the offset and see if that looks any better after recalculating the toolpaths. As the result looks good, we have created a successful toolpath. The last thing I would like to do is go to the first pane in the Preview Toolpaths panel and select Toolpath Color. Open the drop-down menu and select a color that you would like. This will fill in the pocketed area that you have selected from your toolpaths with a uniform color making the lettering and pocket stand out from the surrounding material. We need to do this for each of the pocket toolpaths so that both will be filled with color. By clicking the various icons in the top right of the 3D canvas, we can quickly view our project from different preset perspectives. A more versatile method of viewing our project is to hold down the left mouse button while moving the mouse. Go ahead and try that on your own to see what I mean. You can also use the scroll wheel to enlarge or shrink the project. By clicking and holding both the left and right mouse buttons down at the same time, we can move our project to a different location on the canvas. I prefer this method of previewing the project as I can see it exactly as I like. In this way, you can take a much closer look at the project to assure yourself you're getting the results you expected. The second toolpath that we will create is the V-carve for our artwork. Let's change from the 3D to the 2D view. Deselect the previously selected vectors and select our artwork by creating a rectangle completely encompassing our artwork going from left to right. We will now select the V-carve toolpath, which will open the V-carve toolpath panel and allow us to choose appropriate parameters. Since we will be beginning the V-carve from the surface of the previously carved pocket, we need to enter a start depth of 0.25 inches, which corresponds to the surface of the pocketed area relative to the surface of our material. For now, let's uncheck the flat depth box and then select a tool. Choose the 1/2 inch shank 90-degree V-bit, which is one of the default tools. I'm going to change the spindle speed to 18,000 and leave the feed rate and plunge rate at the defaults. Set the tool number to 3, as this is the third unique tool we have used thus far. Go ahead and apply the settings and close the tool selection window. Back in the toolpath panel, make sure the Use Clearance Tools checkboxes unchecked, as well as the remaining checkboxes in the next 2 sections. Let's rename our toolpath to indicate the tool we are using, and then calculate the toolpath. Let's fill the toolpath machined area with green and inspect our results. Everything is good so far. I want to point out something we should always check with the V-carve toolpath. We want to check the depth of the deepest point in our V-carve to make sure we have enough material left over beneath the deepest point. In order to do that, we will zoom in to the V-carved area and place our cursor over what appears to be the deepest areas, which appear to be in the mountains. While moving your cursor, you will notice the X, Y, and Z coordinates, which represent the location in our material that our cursor would be touching if it were touching the material at that point. We see at this point, which appears to be the deepest point of the V-carve, that the Z coordinate is approximately minus 0.5, which means that the deepest point is 1/2 inch deep into our material, leaving us with 1/4 inch of material beneath the deepest carved point. As this is adequate, we do not need to make any changes to our toolpath. If we determined that the depth of cut was much too close to the thickness of the material, we could correct that by either changing the angle of the bit we are using to a larger angle bit, or check the flat depth checkbox in the cutting depths portion of our toolpath panel, and then enter the maximum depth that we do not want to carve deeper than. Any areas that would have been carved deeper without selecting the flat depth checkbox will then all be carved in those areas to the flat depth selected. Rather than having a sharp point at the deepest area of the cut, we would now see the deepest areas have a flat bottom. The last toolpath that we need to create is a profile toolpath, which will cut out our sign from the material. For this toolpath, we only need to select the outer vector of the sign. So, click that vector and select the Profile Toolpath tool. The next step is to select the tool, and a commonly used tool for this job is a 1/4 inch end mill. Let's select the default 1/4 inch end mill and check the cutting parameters. Let's change the spindle speed to 18,000. Leave the feed rate and plunge rate at the default settings, and change the tool number to 4, as this is the 4th unique tool used in this project. Apply the settings, select the tool, and close the tool database. Again, keep in mind that the settings we choose here need to be chosen to be safe and appropriate for your particular CNC machine. These parameters will not necessarily be safe and appropriate for your particular machine. We will be machining the vector on the outside of the vector, and we will be using climb cutting for our direction of cut. Since we're using a true end mill tool with cutting edges present at the end of the tool, in addition to the sides of the bit, we will leave Ramp Plunge Moves box unchecked. We will check the Add Tabs to Toolpath checkbox and add tabs to our project so that our sign remains attached to the frame after the profile is cut. This prevents the sign from becoming detached from the frame and becoming a dangerous projectile for anything in its path. The length and thickness default parameters are adequate for our purposes, so we will leave them unchanged. Let us now edit the tabs by clicking the corresponding button and specify how many tabs we would like and their precise placement. For this project, we will choose 4 tabs and have the tabs placed to avoid corners and curved regions. Once we add the tabs, 4 icons will appear in the 2D view at the location where the tabs are placed. The interactive tab entry section of the Toolpath tab panel describes how to change the location of a tab, add a tab, or delete existing tabs. I'm going to slightly change the location of the tabs by left-clicking and holding each tab and moving it to the location I prefer. We can now close the Toolpath Tabs panel, rename the toolpath appropriately, and calculate our toolpath. Let's preview the toolpath. The sign looks great. We now have our completed project, requiring us only to remove it from our CNC machine, cut the tabs, and sand the edges smooth. Let's close the Preview Toolpaths panel and click the Save Toolpath tool. This is the step that allows us to save our toolpath files so that we can load them into our CNC software and create our project. If you are using the free trial software, you can follow along, but the Save Toolpaths button will not be usable. We have a few options to choose from. We can save the selected toolpath, which is the toolpath highlighted in blue, or we can save the visible toolpaths all to a single file or to separate multiple files. Visible toolpaths are those toolpaths whose box is checked. If we want to make all of them visible, just check the box to the left of toolpaths. Giving each tool a separate tool number is critical if we plan to save all of our toolpaths to a single file. In this way, when CNC software comes to the next toolpath to carve, it typically prompts the user to switch tools. If the tool numbers are all the same, you may not get a prompt, and your project will most likely be incorrectly carved and probably ruined. For our example, I will select the option to save visible toolpaths to one file, making sure all toolpaths have their boxes checked prior to saving, and move on to the post-processor part of the panel. It is very important to select the appropriate post-processor for your particular machine. Check with your machine manufacturer to determine the correct post-processor. My machine requires the ShopBot TC Inch post-processor, so that is what I will select. I'm not outputting the files directly to my machine, so I will leave this box unchecked. We can then save our toolpaths, giving the file a name and placing it in the location of our choice. We now have our completed project, requiring us only to remove it from our CNC machine, cut the tabs, and sand the edges smooth. Before we finish this tutorial, I would like to show you one more thing that I'm sure many of you will find helpful. If I did not have tabs cut into our material, I could remove the excess material from our image and capture a screenshot of the mock-up of our final product. So let's do that. Double-click on the Profile toolpath, uncheck the addition of tabs, and recalculate the toolpath. Then preview the selected toolpath, and you will see that the tabs have now disappeared. Double-click on the excess material and it will disappear. Go ahead and move your sign to the orientation you'd like to take an image of. Go to the View menu and save your shaded image. You can then name your image and save it to whatever location you like. This is an excellent way to send a mock-up to potential customers so that any changes can be made prior to committing to a project. It's also a great way to make thumbnails for your YouTube tutorial videos. In conclusion, I hope you enjoyed this video. If you did, please give it a thumbs up and subscribe to my channel. Don't forget to click the bell icon so that you'll be notified immediately when new videos become available. Feel free to leave comments or questions, and I'll do my best to answer your questions and use your comments to improve future videos. See you next time.